Welcome to Capitalisn't. I'm Bethany McLean.
And I'm Luigi Zingales.
And we are here to discuss what's working and what isn't in capitalism. Today's topic is may seem a little bit different for us because we have a guest who is a scientist.
So why does a podcast about capitalism want to talk about science? Because capitalism and science were born roughly at the same time. They share a common cultural foundation, and there is a mutual dependency between the two. Modern capitalism cannot exist without the fruits of science, and modern science is supported by capitalist institutions that finance laboratories, R&Ds, and universities.
Their success is intermingled in complicated ways. If per capita income today is 27 times what it was 250 years ago, and if life expectancy is twice as long as it was 250 years ago, is that due to the success of capitalism or the success of science or both?
And the question is, if science is in a crisis, how does this affect capitalism as we know? In fact, we can argue that it maybe it's capitalism itself or capitalist incentives that are responsible for the science crisis. And if we think that science is guided by disinterested inquiry, capitalism is guided by profit. And to what extent is this profit motive impacting science and indirectly the success of capitalism?
Or to what extent is it politics that are impacting both? So to discuss this topic, we are delighted to have with us John Ioannidis, a physician scientist who is a professor at Stanford University and one of the world's most cited scientists. He has more than 600,000 Google citations.
His most famous paper is Why Most Published Research Findings Are False, which started actually the field of meta-science. In it, Ioannidis argued that a large number, if not the majority, of published medical research papers contain results that cannot be replicated.
He also, I think, has additional work showing that citations can themselves be bought. So maybe we should be careful about citing his citations. Anyway, there is no better person to discuss with us the topic of a science crisis and why it matters. So, John, I wanted to start with some of your history. What made you an unorthodox thinker? 20 years ago, you published research, I think it was about 20 years ago, showing that most published claims were false. What do you think it is about your personality that started you down this path?
I'm not sure it's a personality issue. It's just the natural evolution of what I was witnessing and the research that I was doing. And it was just very common to see mistakes, flaws, difficult to replicate, implausible results, very weird claims. If anything, my interest was on rigorous methods. I'm the kind of person who's more interested in methodology rather than the results. The results are interesting no matter what. I think if you use rigorous methods, there's no good result or bad result. They're all results to be respected.
May I suggest that the reason is that you had to spend, I think, 6 months in the military service in Greece after being, I think, a doctor. I had to do 1 year military service in Italy after I got my undergraduate degree. And that made me an anarchist for the rest of my life. So I think
That's a very interesting possibility. I haven't really made the connection, but who knows? I mean, obviously the military is a crazy world, and any notion of rationality and reason probably disappears very quickly.
I did not know that about you, Luigi. So see, all these years into our podcast, and I'm still learning something all the time. I'd love, before we move on to more recent history, I'd love for you to talk a little bit about COVID and what happened to you in the pandemic when you voiced some unconventional views.
I think that it's what happened to many people who voiced any views, not conventional or unconventional. Even the definition of what is conventional or unconventional can be challenged depending on who you ask. I think that many scientists very quickly realize that they either have to completely silence themselves, distance themselves, don't deal with that. It's just a crazy world out there. Or if they continue to be engaged, they took sides. So they said, I need some protection. I need to have a constituency or a side that will protect me. But that probably led to some huge polarizing effect. Personally, I didn't feel that I should seek protection from anyone. I have always argued that politics and this type of forces should not subvert science. They should not affect scientific thinking and reasoning and evidence. So I was just reporting what I found, and that made some people very happy and some others very, very angry. But it's sad that people would not be, or not all people, but some people would just feel that numbers had a color, that they belong to political parties, that they belong to partisan groups, that you had to find one number in order to be a good Democrat or a good Republican or a good supporter of someone. So that's very sad.
But I think that one of the concern was that, of course, COVID was extremely disruptive or potentially disruptive to economic activity. And so the economic incentives to minimize the effect of COVID were enormous. And this is where trust in science came sort of big time, that there was a fraction of the population that did not trust science and did not trust the result. And to be honest, I think that some scientists or pseudoscientists were kind of claiming that the damage were much lower because they wanted to continue business as usual. So I think that this created a fracture in the population about this topic.
I think it's a very complex narrative, and I think what you point out is valid. There was not one or two voices. There were zillions of voices out there. Some of them more rational than others. Some of them just very heavily conspiratorial theories oriented. But many people were dissatisfied with what they saw as science, or what was being sold as science, or followed the science to them. They felt that it was affecting them in multiple ways that were mostly negative. And after a certain point, I think that they generalized their negative response to anything that came out of science. So that science is yet another conspiracy of the powerful against me, against my life, against my family, against my world. It's not for me. It's not trying to help me. It's just trying to make money, help some big tech, some big pharma, some powerful people. It's exploiting me. It's killing me. It's harming me. Not for me. Science is my enemy. Very sad, extremely sad.
But I think that leads into a bigger question that I was thinking about, which is, what is science? How would you define it? I remember my father saying to me at one point, he was a doctor, and I remember him saying to me at one point that all science is a process of asking questions. And I wonder if you would agree with that, or if you would define science differently.
That's a good start. I think it's a process of asking questions and trying to get answers that are falsifiable, that can be checked, that can be evaluated by other scientists, other people, that can be replicated, that can be refuted, that can see their evidence strengthened or weakened in a cumulative way, and hopefully in a transparent way. Now, science, in order to run well, should have some qualities. It has to be disinterested, has to be universal, there has to be communalism, and there has to be a healthy, organized skepticism. And I think that these values have been eroded at times. I think that they were very seriously eroded in recent years. Most people do not see science as disinterested any longer, because there's very strong conflicts of interest. We have been struggling with openness to make science more of a community good, that people can look at data sets, they can look at the codes and the algorithms that people are running to get different results and conclusions, protocols, and how things are done, sharing materials and details about their methods. The large majority of science is not transparent, and it's not possible to just run the machinery that has created it. I think that universalism is something that has created both challenges and advances and problems, because we do see more people doing science. Before the pandemic, I would argue, goodness, why do we have so few scientists? We need more science. We need everybody to be a scientist. And I should have watched very carefully on what I was wishing and saying, because yes, everybody became an expert during these years, and everybody was able to trash the best, most knowledgeable people just with a tweet, completely dismissing them. Um, 20 years ago, the vast majority of research was done in fully democratic countries. Currently, this is some data that I released recently, less than 20% of published research comes from full democracies. The stronger players are either totalitarian regimes. China is currently publishing about 3 times more papers than the US. India is catching up, which is a flawed democracy. It will be number 2 within a few years, outpacing the US. Many other totalitarian countries like Iran see escalating geometrically, not exponentially, productivity in their papers. Are they real? Are they fake? We have evidence that some of that is really fake, no more than that. And organized skepticism, goodness, we've seen it weaponized. We've seen it go completely off target. We've seen it suppressed also and censored and attacked. It's a very delicate good. Organized skepticism is something to be respected and allowed to grow in a healthy way. And people have very different notions about what is healthy skepticism. We have so many influencers that completely overshadow the landscape of what it means to be a skeptic, a healthy skeptic.
I guess that in that statistic, you consider the United States as still a full democracy, because when you see that, I know, so the 20% does not include the United States.
It does not include the United States in the last 10 years, roughly. Yeah, the United States is a flawed democracy in the last 10 years, roughly.
Why does that matter for science? Why can science not be done effectively in a totalitarian regime? Why is science, it sounds like part of the argument you're making is that science is best practiced in a democracy, or most fairly practiced in a democracy, maybe. Is that the argument, and why would that be the case?
It's not really my argument. I follow that argument, but it's something that has been expressed for many years, decades. I think that the classics in sociology of science have traditionally said that you need democracy, you need freedom of speech, freedom of thought, freedom of writing and publishing, whatever you want to do and say and express in order to have science. And it makes sense that if science is this questioning, if you cannot really ask the questions that are important, or if you need to get answers that satisfy some regime or some of the entities that support or benefit from that regime.
So I expected a slightly different answer, because you're one of the founder of the evidence-based medicine against what you call the eminence-based medicine. So I expected you to sort of say that totalitarian regimes are more naturally supporting eminence-based medicine. But can you explain to our listeners what is evidence-based medicine, and why, from a strong supporter, you started to be a critic more recently?
So eminence-based medicine means that you give more weight to people who have higher titles, more prestigious titles. They're professors, and their opinions should carry more weight. Evidence-based medicine, conversely, is using results that are numbers, or could be qualitative research sometimes, but it is evidence. It is not opinion. Now, is totalitarianism in favor of eminence or evidence? It could be either way. I think that totalitarianism may use experts that are aligned with the regime, that are just easy to buy, or just make them align their thinking and their beliefs, or perhaps even silence if they're contrarians. But it could work also through an quote-unquote evidence approach. It could try to get studies, and perhaps with a little bias here and there, it could also create an environment where seemingly there is enough evidence for things to be done in a given way. So I think that eminence-based approaches have become less tolerated over time as people in evidence-based medicine have tried to make the case that they're not reliable, and they're not reliable. It's less likely that people who want to subvert evidence will just present crude, raw eminence in defense on whatever they do. Usually they will try to do it by supplying things that look like good evidence, but actually it is not, and then build the case along with the wrapping of opinion and policy and whatever else.
But it seems that you've become something of a skeptic, or at least a little bit worried about evidence-based medicine too. And is that because we're in a place where what is actually eminence is disguised as evidence? Has that been because the boundaries between the two? Is that because the boundaries between the two are more blurred than you would like to see, or has been some more profound failure of evidence-based?
I think we've seen profound failures of evidence-based approaches, or so-called evidence-based approaches. Somehow eminence-based approaches hijacked evidence-based terminology. So you have the most eminence-based approaches hijacking the name evidence-based and using it to their benefit. So you have guidelines, even in the field of cardiology, that has more evidence than any other medical field. Nevertheless, more than 50% of the recommendations in guidelines of cardiology, like the best cardiology guidelines, they're just based on eminent opinion, kind of what experts believe. There's no evidence for them. And when there is evidence, it is being oversold much of the time. Also, many of the tools of evidence-based approaches have become so widely misused that you have to be very careful. I have been a very strong supporter of the need to perform evidence synthesis, put the results of multiple studies together on a given topic, perform systematic reviews and meta-analysis. Again, I should have been very careful about what I wished, because now we see a pandemic of systematic reviews. There's some topics for which we have 100 systematic reviews on the same topic. There's absolutely no reason to have such redundancy. And out of the 100, all of them are very poorly done sometimes. So it is a factory producing lemon cars, and people just love them because they have the stamp of evidence-based medicine, supposedly, but they're just, products that should have no value and should be discredited.
But there seems to be a little bit of a apparent contradiction between your support for evidence-based medicine and the fact that your most famous paper says that most published research findings are false. Because how can you, if most research findings are false, what is the evidence?
Yeah, well, it is the way that 20 years ago when I published that paper. Unfortunately, even now, I think if you take a random paper, just from the 7 million papers that are published every year, if you pick a random one that makes a new claim, it's more likely that it will be false than it is correct. Even though we have seen some structural reforms and some improvements in several fields, but not all fields. Some of the worst fields that were the least reliable have been the ones that have grown completely unchecked and to gigantic proportions, publishing amazing quantities of papers that are unreliable. So the notion that we need evidence-based approaches does not mean that every piece of evidence is to be believed and worshipped. Actually, it needs to be scrutinized, it needs to be checked, it needs to be perhaps reproduced or triangulated somehow. And then, perhaps we can take it to the bank and make some use of it.
What is more dangerous, a totalitarian society practicing science, or a society, and here's where I'll invoke Luigi's hatred of the economy and the pandemic with my own hatred of the economy now, with a society that has the wrong economic incentives for its scientists practicing science?
I think they can both be bad. I think that, wrong incentives, wrong financial incentives for scientists, even in democratic societies, can be problematic. People are not rewarded for doing rigorous science. They're not rewarded for questioning their own results. They're not rewarded for finding something and then being skeptical about their own findings and perhaps dismantling their own findings if they find that was due to some bias or some winner's curse finding that gets refuted downstream. They're rewarded to come up with extreme, extravagant, eventually unbelievable much of the time results that do not really offer much for progress in science, let alone for society.
But speaking of structural incentives, hopefully I don't misquote you, and feel free to tell me that I'm completely wrong. But one of the things that intrigued me of what you're saying is that there seemed to be a structural tension between evidence-based medicine and the way we finance research, for example, in the pharmaceutical sector, because the pharmaceutical sector owns the data, finances and owns the data that, in principle, should bring to its own demise. And so there is you can't basically get serious research done in this situation. Isn't that the case?
There's clearly a conflict here. If we ask the pharmaceutical industry to really come up with the research that will show that their products are good to go and good to market and good to buy and good to make profit. And I think that this is a misallocation of resources. I think that the testing of the products that pharmaceutical industries develop should be done in an independent way by independent stakeholders with public funds. I have proposed even ways that this could be financed. For example, it could be financed with some money from the pharmaceutical industry still, but that would go to a common pool where independent investigators would be able to use to ask the most relevant questions about these products in a more rigorous way, in a more appropriate and biased way. And I think that currently most of the public funding, like NIH, for example, goes into supporting research that probably should be done by the industry. For example, supporting research that is not fully basic science, which I believe public funds should go to. Basic science means you don't know what you're seeking and what you're trying to find. You're going into the jungle and who knows what will come out of it. You cannot promise a deliverable. You cannot promise a product that will come out of it. Maybe hundreds of products will be based on that research eventually, but you just don't know that. You need to be free to explore the jungle. And I think this is fine, to have public funds go that way. But the vast majority of public funds go to translational research where, in theory, there are deliverables. There are products, drugs, devices, biologics, vaccines, tests, whatever, that are to be developed. And I think, this type of work should be done and funded by the industry. They have every reason to want to develop drugs, devices, biologics, vaccines, and tests. That would be the best. They would have the best performance, the best effectiveness, the best accuracy. So I think that they should do that research instead of having all the public funds go in that direction. Instead, the final testing of which of these products is the best, which one is better than nothing, which one is better than the standard of care that we have now, that should be done by independent investigators and currently done by the industry that has every right to do whatever is in their remit to show that their products are the best, and they need to be licensed immediately, and they need to be sold widely, and they need to be even mandated if possible for everyone, and make tens of billions out of it. I cannot blame them. They're just like painters who are asked to appraise their own paintings and give the prize of which painting is best. What is the likelihood that they will not try to show that they are the best painter on earth?
What is that trade-off with public funds when you think about maybe a sort of old school model of just go explore the jungle and let's see what ideas come versus a more new school model of we need deliverables to make sure money is being well spent? How do you sort of toggle between those two ideas? Or should it be just this purity that if it is public funds, then it is the purity of exploring the jungle?
I think the common denominator should be transparency. When you go into the jungle, you can still have a travel log and record. Today I saw a pink panther. Tomorrow I saw a python. The next day I fell into a trap. Keep a log, and people will know. John went into the jungle. This is what he did. This is what he encountered. This is what he found. Now let's see if others can find the same signals or the same patterns, and perhaps some of that is useful, and we can take it to the next step of experimentation. Now, again, this needs to be funded by public funds. You need to have bold people, innovators, disruptors, people who want to venture, who want to go to the jungle, to run the risk of falling into a trap, to meet a panther, to meet a python, and fail, very often fail. But one of them might succeed. And that in the long run is shown to have benefit. No industry is going to fund that. There's no immediate profit for them. They cannot wait for 10, 20, 30, 40, 50 years, who knows, for that to be translated. Then you have other things that need to be publicly funded, like the clinical trials or the evidence-based approaches that I mentioned, that should be independent from the industry. And there, transparency means a very detailed, pre-specified, accurate, complete protocol.
So, as an economist, I'm embarrassed to say that you're doing something that we economists should be doing, but we're not, which is to bring incentives into research. What I find it amazing is that economists think that everything is motivated by monetary incentives except research, and they think that every human respond to incentives except economists that are angels and they don't respond to incentives. I think that it's very healthy to bring this evidence. So let me provoke you with one idea that I've not seen. Maybe you have written a paper about this, but I don't know all your papers because you've written so many. But when there is a very strong incentives to find a particular result, and you know there are a lot of researchers that are trying to find a result. Why? Because the data are available, and you know that this is a good result to have, and the result is not there in the literature. Can you say that lack of evidence is evidence of lack of an effect?
The classic answer, no. Lack of evidence is not evidence for lack of an effect. There's so many questions for which we have no evidence, or we have very poor evidence that you can very quickly say, goodness, that's like we have no evidence at all. We need evidence for these questions that we don't have some data to support one or another answer.
But when you know that there are a lot of researchers that will try to get, and you know that null results rarely get published. So let me make an example. In the past, there was a lot of interest in showing that countries with the largest stock markets were growing faster. And there is no paper I know that basically shows that. And can I infer that basically the correlation is zero? Because I know that a lot of researchers, and I'm one of those, but a lot of researchers have tried to find that correlation and they fail. And so can I make that conclusion?
Sometimes you might, if something is so easy to address, so easy to tackle, so in front of your eyes, at the tip of your fingers, anyone with a laptop can access data sets and probe that correlation within minutes, if not seconds, and you see no literature. I mean, it's not paranoid to think that many people have really just clicked on their laptop and have tried to get an answer, and there was not an answer that they felt was publishable. I see that very often in some very common medical fields where you look at the literature, there's very little, and you say, goodness, that's something that tens of thousands of data sets can immediately address if someone wants to address it. What's going on here. Now, you take the paranoid step. So this means that they found a negative result. It's a paranoid step, but it is probably likely to be true. If it's something that is so easy to do and no one has reported, most likely it is null or something that people don't want to hear about. Conversely, if it's a question that you only can answer if you have private access to Hubble or Webb telescope, and everyone can know who has access to that, that's clearly a very different story. You have to say no one can really attack that question. The one means that is available, we know that no one has done that, has not looked in that direction of the galaxy. So there's nothing unpublished. So it takes a little bit of understanding of how a field works and its whereabouts in terms of who is doing what kind of access people have to technologies and methods and tools to generate data, and also what is the culture in the field in terms of tolerating negative results. There's some fields that have no problem with negative results nowadays for various reasons. Perhaps if, for example, you work in genetic epidemiology, you test every little polymorphism in our genome for association. And, there's no reason to hide some of these polymorphisms from the publication of the results. You just show, here's the entire sequencing, here's the entire genome that I have tested, and this is the results that I have found. Some of them are significant, others are not significant. If you try to eliminate some, people will notice. They will say, what's going on here? Why are you showing me only 22% of what obviously you have tested? So there are some settings where publication bias does not exist. There's even some settings where publication bias exists in an inverse mode, where people prefer negative results. For example, studies of harms of medications. The industry does not want to hear anything about harms. They will do their best to suppress studies that show harm signals, downplay them, not publish them, make a story these are conspirator theories who are talking about harms. The incentive is against positive results. Or people like me who want to show that results are null. I have a bias to show negative results. So who knows? If you have more people like me, maybe you will get more disincentives against positive results. Replication, I don't want to hear about replication. That will mean that my papers are not replicated. I'm kidding, but who knows?
Is there a way to draw a clear line between mistakes that may arise from very human cognitive biases, but are not mistakes because of bad incentives, and mistakes that are made because of bad incentives? And how do you think about each category of mistakes?
I think the two categories interact. I think that you may have cognitive biases, and this may make you more receptive to doing some research that also has financial conflicts or other more overt conflicts that lead to a particular result. Or conversely, maybe you avoid that explicitly. I think that what we need is transparency, and transparency regarding the financial components should be the easiest to attain, but we know that we have not attained this, even that. I'm not going to dismiss a study because it is funded by a potentially conflicted stakeholder, but I just wanted to know. And I think that it could be done very well. Who knows? And it may be the best study in the field. But I think it's good to know that this is who has supported it and what kind of involvement they had. Was it that they just get the money and then they shut their eyes? Or did they run the protocol? Did they run the analysis? Did they write the paper? Did they do everything? And just asked a couple of Stanford and Harvard and University of Chicago professors to put their names to just gain the eminence prestige. Now, the allegiance and cognitive biases are more difficult to decipher. Again, I think we can do a little better in disclosing some of the possibilities. For example, advocacy and activism, especially when it's publicly declared previously. I see no reason why people should not say so. They should be proud. I'm an activist for climate change to be taken seriously. Good for you. But just tell me about it. I'm an activist in trying to get rid of SARS-CoV-2. Thank you very much. Just tell me that you're an activist, and what kind of activism are you proposing? Because maybe what you propose is very reasonable, or maybe it's a little weird, but whatever it is, you should be proud that you're an activist, so you should disclose it. But we don't see that disclosed. We had a situation with a paper published in Nature where out of 100 roughly such conflicts of interest of intense publicly disclosed activism for something that, as a theory, zero COVID is like equivalent to flat Earth nowadays. But you had all these people believing that SARS-CoV-2 should be eliminated. Only one of about 100 was disclosed. Why? They were proud to do this. I think that they should have disclosed what they had done and what they were struggling to save the world with. So some of that could be disclosed. Some other aspects are very difficult to disclose. If I like the Mediterranean diet, I'm not an activist of the Mediterranean diet, but I do like Mediterranean diet. Should I disclose that if I do nutrition research? Should I tell you what I ate today for breakfast or what I will eat for lunch? That's getting very messy. But at least some aspects, I think, could be more clean, more disclosable, and more believable eventually, because currently these disclosures are so empty that people justifiably say, I don't believe it. That's just hidden under the carpet.
I'm sorry to say, but with a last name like Ioannidis, you don't need disclosure on the Mediterranean diet. People just assume you prepare it.
Everybody will notice.
Yeah.
So we're almost out of time, but I had a last question. You'd mentioned back at the beginning about being an effective skeptic. How would you define, or how would you recommend somebody go about being an effective skeptic?
Goodness, I would have to be an expert to start giving admonitions here, but I think we start from our own selves. I think that I study bias, so I must be very biased. So I always try to look at what I say and write. It's more difficult to look at what you say because it's done deal, like in a podcast. But at least what you write and what you publish, you have to look again and again and again, and try to get some contrarian to your views, to look at it and try to see what their arguments are, and where you think that you can meet their arguments or rebut their arguments, or perhaps agree that they may be correct in what they challenge. And be open to ask for replication, strategically placed replication. Be ready to alternative possibilities. Don't be inflexible. Science is self-correcting, and I think that we should be happy with whatever the results are. Don't start a study with a preconceived notion that this is the result that I want to get. If you do a study to get a particular result, probably we're off in a wrong foot. We run a study because any result in one or the other direction or null is going to be very interesting. It will change our information landscape, no matter what the result is. So I'm not sure. I think that it's something that needs training, and it needs consistency and persistence to overcome these biases that are innate. They're part of how we think and how we work.